We have had a history of various kinds of antibiotics, which were first discovered in 1946 with penicillin. Then soon after that, we had strep and staph infections that would be very sensitive to penicillin. Today, 80% of all strains of Staphylococcus, are resistant to penicillin. This was quite a shock to us. 1950, we had more antibiotics that would infect multiple bugs: streptomycin, chloramphenicol, tetracycline. Then in 1953, there was a Shigella outbreak in Japan, and it resulted in the appearance of a strain of dysentery bacillus that was resistant not just to one antibiotic, but to many. And that was a red flag, and people started becoming somewhat concerned. Up now to 1982, when we had the last new class of antibiotics, the quinolones, resistance is rising really in a frightening manner. Shapiro, to which we were eating like candy when there was an anthrax scare in the United States, has caused enormous resistance to that particular drug. 1998, vancomycin, which is considered by many an antibiotic of last resort for staph infections and other kinds of pathogens, we are now seeing the emergence of resistance to vancomycin as well. Now, what happens when something becomes resistant to an antibiotic is it turns out that these bugs are very, very smart. And what they have learned how to do is if they see a drug coming towards it, like erythromycin, it figures out how to spit it out. Or if the antibiotic manages to get into the bug, the bacteria have figured out a way of chemically modifying that antibiotic so it's no longer working. And they also have figured out how to change the target of that antibiotic in that particular cell so it doesn't work any longer. So these bugs are very smart, and we're in a war with them, and the bugs are winning. And what we need is to understand how to make new and better antibiotics. If I just look at staph infections in the United States, in 1957, 100% sensitive to penicillin. 1982, fewer than 10% of all staph cases could be cured by penicillin. 1993, only vancomycin survived as an effective antibiotic. And today, as I've told you, there are strains that are resistant to everything.